Hi, today we're talking about slope intercept form. I kept this one to the last day because I feel like it's the one that you're probably most familiar with. Y equals mx plus b can be used to represent the equation of a line. So in this case, the m and the b are values and they represent specific things or in the context of our problem. So m will always be the slope. So we're going to start with the slope of 2. And then we have a y-intercept, which is the b. So the y-intercept in this case is -5. Our equation will be y equals 2x minus 5. Let's start with our table of values. This one's a little bit harder to start with the table of values, but really what you can do is just test different values of x. So I like to start with negative values, -2, -1. Make sure you get 0 and then 1 and 2. So we're picking just random x values, but I like to do them around what the center of the graph would look like. And now that we've found x values, we can plug them into the equation to find the corresponding y values. Okay. So with the first x value of -2, 2 times -2 is -4, and then we're subtracting 5 from that. So we get -9. 2 times -1 is -2, minus 5, -7. 2 times 0 is 0, minus 5, -5. And you may see a pattern here forming that our y value is just going up by 2 each time. So we get -3 and -1. The fact that that y value is going up by 2 is not we can tell that just from the slope. So we could have done it by slope as well. Okay. Using the table of values or the equation itself, we can graph. So when it's in slope-intercept form, what you want to do is start with the y-intercept. So in this case, the y-intercept is -5. And then it has a slope of 2. So we are going to use rise over run to find our next point on the line. So our slope is 2. We can think about that as 2 over 1. That for each additional 1x, our slope is going up by 2, or our y is going up by 2. Rise by 2, run by 1. Rise by 2, run by 1. After you get a few points, try and do more than 2. Technically, you only need 2, but just to play it safe, do at least 3 or 4. Okay. So that would be the equation, or the graph of our line. What would be the x-intercept? Well, I can tell from the graph that it's going to fall somewhere between 2 and 3. I'm not really sure where. So what we can do is algebraically find that x-intercept. The x-intercept occurs when y is 0, so it's like some number comma 0. So we're going to plug 0 in for y and solve for x. 0 equals 2x minus 5. Add 5 and divide by 2. X is 5 halves, or you can think about it as 2.5 as well. Okay, so our x-intercept is the ordered pair 5 halves comma 0. Okay, so now that we've had some experience working with slope-intercept, let's do another one. Write the equation a line passes through -1 comma 2 and 7 comma 6. We need to find both the slope and the y-intercept. So let's start with the slope. To find the slope, it's the difference in y's, 6 minus 2, divided by the difference in the x values, 7 minus -1. Okay, 6 minus 2 is 4, 7 minus -1 is 8, and that reduces to 1/2. So we have a y-intercept of, or not a y-intercept, a slope of 1/2. So we have the equation y equals 1/2 x plus b. We need to find b. So what we can do is take one of the ordered pairs, and it doesn't matter which one, but we're going to plug it in for x and y here and use it to solve for b. Okay. I'm going to pick the first ordered pair, -1 comma 2. So the y coordinate is 2. 1/2, x is -1, and then plus b. So that is 2 equals -1/2 plus b. And then we can add 1/2 to both sides. 2 plus 1/2 is 5/2. Is that a fluke? I don't know. It must be. I think these were 2 random points. So now that we found our y-intercept, y equals 1/2 x plus 5/2. Traditionally, if you write your fraction if your slope is a fraction, write your y-intercept as a fraction as well. You want to keep the form of these two numbers the same, either both decimals or both fractions, but always keep them exact. Okay, let's look at an application problem. Oberon Cell Phone Company advertises service for 3 cents per minute plus a monthly fee of $29.95. If Parker's phone bill for October was $38.95, find the number of minutes he used. Okay, we're going to write the equation, y equals mx plus b. To do that, we need to define what x and y are representing. I'm going to do that after I plug in my values because it might help me to determine the context of what those values are. So y equals m, our rate of change is like it should be a rate. So I'm going to use the 3 cents per minute, 0.03 x, and then plus b is the constant. So it's a monthly fee of $29.95. Based on how I wrote my problem, I'm going to be taking the cents per minute and multiplying it by number of minutes. And then y is going to be the total cost. So we are given $38.95, and that ends up being the total cost for the month of October. We can use that to solve for the number of minutes used, which is x. So $38.95 minus 0.03 equals 0.03x plus $29.95. Okay, solving for x, we're going to subtract $29.95 from each side. $9 equals 0.03x. So what that tells me is we were using $9 just on the 3 cents per minute. And then we can divide 9 by 0.03. X equals 300. So we have our solution. We need to answer the question. The number of minutes he used was Parker used 300 minutes, and there's the answer to the question. Lastly, parallel and perpendicular. So write the equation of a line perpendicular to the one given that passes through -9, 8. All right, what we want to do is start with our perpendicular slope. So our slope right now is 2. We want to do the perpendicular slope, which is the opposite reciprocal. The opposite is that it's negative, and then the reciprocal is that it's 1/2. So our new slope is -1/2, and we know that it passes through -9, 8. All right, so I'm kind of thinking ahead here. I need to find b, or I need to find the y-intercept. So I'm going to plug these coordinates in for x and y. So 8 equals -1/2 times -9 plus b. All right, this is 16/2 equals a positive 9/2 plus b. So I can subtract 9 from each side. 16 minus 9 is 7. So 7/2 equals b. So our equation is -1/2 x plus 7/2. Kind of hard to see that negative. There we go. Okay. And last example, Write the equation of the line parallel to the one given that passes through 5, 6. Parallel lines means the slope is the same, so we're going to use the slope of 2. I'm going to think ahead here, plug in x and y so that I can solve for b, or the y-intercept. So 6 equals the slope times the x value plus b. 2 times 5 is 10, so I'm going to subtract 10 from each side. 6 minus 10 is negative 4. So our y-intercept in this case is negative 4. Y equals 2x minus 4 will be the parallel line that passes through 5, 6. All right, that's it for tonight. Thanks.